There is one ingredient sitting in almost every kitchen in America right now. Most people use it every single day without thinking twice about it. It has been recommended for decades, advertised as heart healthy, printed on labels that suggest you are making the smarter choice. And for years, people trusted it completely. But what many adults over 60 were never told is that the brain may respond to it very differently than the heart. People are told this is simply aging, but new research is pointing towards something much more specific. And the most unsettling part, the cause may already be sitting in your kitchen right now. In the next few minutes, I am going to show you what this ingredient actually does inside the brain. I'm Dr. Gloria Reed. For more than 20 years, I have worked in nutrition, neurology, and cognitive aging, helping people understand what really affects the brain as we grow older. And before we get into the science, I want to give you something practical, something simple you can start using immediately, before this video is even over. Here it is. Starting tomorrow morning, switch every cooking application that uses high heat, frying, sautéing, roasting, to extra virgin olive oil or grass-fed butter. Nothing else, just that one change. Here is why this matters immediately. When seed oils, canola, soybean, sunflower, are heated above 320 degrees Celsius, which is the temperature of a normal sauté, they break down and produce a compound called 4-hydroxynonenal, or 4-HNE. That compound is lipid-soluble, which means it does not stay in the pan. It crosses the blood-brain barrier and accumulates specifically in brain tissue. Extra virgin olive oil, when kept below its smoke point of around 375 degrees Celsius, does not produce 4-HNE. Grass-fed butter does not produce 4-HNE. The switch is that direct. You do not need a new pan. You do not need a new recipe. You need a different bottle on the counter. Keep that in mind, because when I show you the full protocol later, this first step is what makes everything else work. Stopping the source of the damage is always the first move. What comes after it accelerates the recovery. But none of the recovery works if the damage keeps coming in every single day. Most people believe that the oils labeled heart healthy on the grocery shelf are generally good for you, and that is not entirely wrong. Some of the research supporting those claims is real, and the cardiovascular picture is genuinely complicated. But here is the part that changes everything, and that almost nobody explains. The brain is not the heart. The brain is 60% fat by dry weight, and the specific types of fat inside neurons determine how well those neurons communicate with each other. The brain does not just tolerate lipids, it is made of them. And that means the brain is uniquely vulnerable to what happens when dietary fats go wrong. The villain in this story has a name: lipid peroxidation. When polyunsaturated fatty acids, the primary fats in seed oils, are exposed to heat, oxygen, and light, they oxidize. They go rancid, chemically speaking, even before they reach your pan. And when that process happens inside a hot skillet, it produces a cascade of reactive compounds, the most damaging of which is 4-HNE. Think of it this way. Seed oils, once heated, are chemically fragile. They are like a rubber band that has been left in the sun. It looks intact, but the molecular bonds are already breaking. Heat is the final stress that snaps them, and what comes off those broken bonds is not neutral, it is neurotoxic. 4-HNE crosses the blood-brain barrier because it is fat-soluble. Your brain's fatty membrane structure is exactly what allows it in. Once inside, it binds to proteins in neurons, disrupts mitochondrial function, and triggers a cascade of oxidative damage that specifically targets the hippocampus, the memory center, and the prefrontal cortex, where concentration and word retrieval live. Before I go further, have you already switched away from vegetable oils, but still noticed your memory or focus has not improved? Just comment yes or no below. because what I am about to show you is specifically about what happens after you make the switch, and why the damage that is already there needs active repair, not just removal. Let me make the first mechanism completely clear, because most people have heard that oxidative stress is bad without ever understanding what that actually means inside the brain. Every neuron in your brain is enclosed in a membrane. That membrane is made of fatty acids. Those fatty acids determine how fluid the membrane is, and membrane fluidity determines how easily electrical signals pass from one neuron to the next. When you remember a word, when you follow a conversation, when you recognize a face, all of that is electrical signaling moving through membranes made of fat. Now here is what 4-HNE does when it enters that environment. It binds to the proteins embedded in those membranes. It stiffens them. It disrupts the ion channels that regulate the electrical signal. The membrane goes from fluid to rigid, from a functioning communication cable to a fraying one. The analogy that makes this precise: think of the myelin sheath, the protective coating around nerve fibers, as the rubber insulation on an electrical wire. Healthy lipids keep that insulation intact and flexible. Oxidized lipids are like pouring corrosive acid on the insulation. The wire is still there, but the signal leaks, misfires, arrives slow or not at all. The cognitive experience of that damage is exactly what you feel. The word that should come instantly now takes 3 seconds. The thought you were holding slips before you finish the sentence. The name you know perfectly well simply refuses to surface. This is not a metaphor for what might eventually happen. For people over 60 consuming heated seed oils daily, this is what is happening now, accumulating with each meal. The research that clarified this mechanism most precisely came from a 2009 study published in the journal Brain Research, led by Dr. Nasser Bouri and colleagues at the Institut National de la Recherche Agronomique in France. Their work demonstrated that 4-HNE accumulates preferentially in hippocampal tissue and directly impairs long-term potentiation, the cellular process that is the literal biological basis of memory formation, not memory recall, memory formation, the encoding of new information. What this means in practical terms: the problem with prolonged seed oil consumption is not just that it damages existing neurons, it is that it progressively impairs the brain's ability to build new memories, while the old ones are also being degraded. Both directions at once. Extra virgin olive oil, by contrast, is rich in oleocanthal, a polyphenol that research from the University of Louisiana's Department of Basic Pharmaceutical Sciences, led by Dr. Amal Kaddoumi, has shown to enhance the brain's own waste clearance mechanism, the glymphatic system. The replacement is not neutral, it is active neuroprotection. This is where the ACAO immediata you received earlier fits directly into this mechanism. Switching to olive oil for high-heat cooking does not just remove the source of 4-HNE, it begins replacing damaged lipids in neuronal membranes with oleic acid, a stable monounsaturated fat that does not oxidize at cooking temperatures and that actively supports membrane fluidity. The second mechanism is related to the first, but it operates at a different level, and understanding it explains something that confuses a lot of people: why switching oils helps with memory specifically, and not just general inflammation. Neurons are the most energy-demanding cells in the human body. Your brain is 2% of your body weight and consumes 20% of your total energy. That energy is produced in mitochondria, the power generators inside each cell, and those mitochondria are extraordinarily sensitive to oxidative stress. Here is how 4-HNE targets them specifically. Mitochondria produce energy through a chain of protein complexes. complex I through complex Y, each of which requires intact protein structures to function. 4-HNE binds to the proteins in complex the Y and complex II, the earliest stages of that chain. When those proteins are damaged, the mitochondria cannot complete the energy cycle. ATP production drops. The neuron becomes energy-starved. Think of it this way. A neuron running on damaged mitochondria is like a hospital running on a generator with a failing fuel pump. The lights are on, the machines are running, but at 40% capacity. The hospital is technically functioning, but the most complex operations cannot be performed. In the brain, the most complex operations are working memory, word retrieval, focused attention, and the formation of new memories. Those are the first functions to fail when neuronal energy production drops. The practical consequence in daily life, the fog that descends after a high-fat, high-heat cooked meal. The afternoon thinking that is noticeably slower than morning thinking. The difficulty concentrating for more than 20 to 30 minutes. These are not personality traits or laziness. They are downstream effects of mitochondrial function being chronically suppressed by oxidized lipid intake. A 2011 study, published in Free Radical Biology and Medicine, from research conducted at the University of Kentucky's Sanders Brown Center on Aging, demonstrated that 4-HNE is detected at significantly elevated levels in the brains of individuals with mild cognitive impairment, at concentrations high enough to produce the mitochondrial disruptions described above, specifically in hippocampal and cortical tissue. These two mechanisms, oxidative membrane damage and mitochondrial suppression, do not work in isolation. They feed each other. Mitochondria that cannot produce enough ATP cannot power the antioxidant enzymes that would otherwise neutralize 4-HNE. The oxidative load increases. More membranes are damaged, which further stresses the mitochondria. The cycle compounds silently, meal after meal, year after year, and that is exactly why addressing both simultaneously, removing the source and actively repairing the damage, produces results that removing the source alone never does. Before I walk you through exactly how to do this, I want to be direct with you. What I am describing is not a replacement for medical care. If you are on medication, especially any blood thinners or anti-inflammatory drugs, speak to your doctor before changing your diet significantly. What this is an evidence-supported, low-risk nutritional shift that works alongside what you are already doing. Most of what I am about to describe costs nothing to implement. Most people who decide to switch away from seed oils make one mistake that significantly reduces the benefit, sometimes cancels it entirely. They switch to the wrong olive oil. Here is what happens. A person reads about the dangers of canola or soybean oil, goes to the grocery store and picks up the bottle that says olive oil. The light kind, the refined kind, the one in a clear plastic bottle on a shelf in full light. And they feel like they have solved the problem. They have not. Refined olive oil, sometimes labeled light or pure olive oil, has been processed at high temperatures to remove the flavor. That processing removes the polyphenols. Oleocanthal is gone. The anti-inflammatory and neuroprotective compounds are gone. What is left is a fat that is more stable than seed oils, but that delivers none of the active neurological benefit. It is a downgrade from canola in terms of damage, but it is not a solution. The correct form is extra virgin olive oil, cold-pressed in a dark glass bottle, purchased in a quantity you will use within 60 days of opening. The extra virgin designation is not a marketing term. It is a legal standard that guarantees first cold pressing, meaning the polyphenols are intact. The dark bottle matters because oleocanthal degrades under light exposure within weeks. Here is the correct way, the full protocol. Step 1. Remove and replace. Days 1 through 7. Go through your kitchen and identify every oil that is a seed or vegetable oil. Canola, soybean, sunflower, safflower, corn oil, vegetable oil, which is almost always soybean, and any generic cooking sprays. Set them aside. You do not need to throw them away immediately, but remove them from daily use. Replace your primary cooking oil with extra virgin olive oil for all applications below 375 degrees. That covers sautéing, roasting vegetables, salad dressings, and finishing dishes. For applications above 375 degrees, searing, high heat stir fry, use grass-fed butter or refined coconut oil. Both are saturated fats that are structurally stable at high heat and do not produce 4-HNE. Do not use extra virgin olive oil for high heat searing. Above its smoke point, it does oxidize, not to the degree of seed oils, but enough to reduce its protective compounds. Respect the temperature range. Step 2. Introduce astaxanthin. Starting day 3. Switching oils removes the source of ongoing oxidative damage, but the damage already in brain tissue does not reverse on its own. It needs active neutralization. The most targeted tool for that is astaxanthin, a carotenoid produced by microalgae, the same pigment that makes salmon pink. Astaxanthin is the most potent antioxidant known to cross the blood-brain barrier, with a singlet oxygen-quenching capacity 6,000 times greater than vitamin C and 800 times greater than CoQ10. Take 12 milligrams of astaxanthin daily with your largest meal of the day, the meal that contains the most dietary fat, because astaxanthin is fat-soluble and absorption is directly tied to the fat content of the meal. Do not take it on an empty stomach. Do not split the dose. 1 12 milliounce capsule once a day with food. Do not combine with blood thinners without consulting your doctor. Astaxanthin has mild anticoagulant properties. If you are on warfarin or similar medications, this is a conversation to have with your physician before starting. What to expect? By day 7, the change is likely subtle, but specific. People commonly report that the afternoon cognitive fog is slightly less dense. The post-lunch mental slowdown that feels like a wall coming down, that wall becomes a speed bump. That is mitochondrial recovery beginning. The neurons are receiving more ATP because the oxidative interference has begun to drop. By day 14, the change becomes more concrete. Word-retrieval, the specific lag between knowing a word and being able to say it, begins to shorten. Not dramatically, not overnight, but the pauses get measurably shorter. People start completing sentences without the brief stall. This is membrane fluidity beginning to improve as damaged lipids are gradually replaced by the stable oleic acid from the olive oil you are now using every day. By day 30, the cumulative effect is noticeable enough that people around you may comment, not on what you are doing, on how you seem. More present in conversation, sharper in responses. The mental effort that cognitive tasks used to take, following a complicated conversation, remembering a sequence of steps, that effort decreases. Not because the work is different, because the brain doing the work has been gradually deprived of the compound that was suppressing its mitochondrial function. Remember what I described at the start. The ingredient in almost every kitchen that people have been told is healthy. By day 30, most people who make this switch feel, concretely and specifically, the difference between what they were operating on before and what they are operating on now. That difference has a biological explanation. And now you know exactly what it is. Before I close, 3 supporting factors that amplify what you are already doing. Each one takes less than 5 minutes. First, sleep on your left side. During sleep, the glymphatic system, your brain's overnight waste removal network, clears the oxidative byproducts accumulated during the day. Research from the University of Rochester demonstrates that lateral sleep position increases lymphatic clearance by up to 25% compared to sleeping on your back. The left side specifically reduces cardiac strain and keeps the clearance pathway open. When you switch oils during the day and clear the damage at night, you are working both ends of the cycle. Second, a 10-minute walk after your largest meal. A post-meal walk at a gentle pace, not exercise, just movement, reduces the post-meal blood glucose spike that activates the lipid peroxidation pathway in neurons. Even without a dietary change, a 10-minute walk after dinner has been shown in studies from Stanford's Human Performance Lab to reduce post-meal glucose elevation by up to 30%. With the dietary change, it accelerates the recovery timeline you would otherwise see only at day 30. Third, 4 counts in, 6 counts out, 5 minutes before you look at your phone in the morning. This specific breathing ratio, longer exhale than inhale, activates the parasympathetic nervous system and suppresses cortisol release. Elevated morning cortisol accelerates lipid oxidation in the brain. 5 minutes of structured breathing before your first screen contact resets the hormonal baseline for the day. Here is what we covered today: the specific mechanism by which heated seed oils damage the brain, the 2 biological pathways involved, oxidative membrane damage and mitochondrial suppression, and a step-by-step protocol to stop the source and begin reversing the damage. Your brain did not develop this vulnerability in a week. It will not fully recover in a few days. That is biology, not failure. What the research shows consistently is that targeted, specific action over 30 to 90 days produces changes that are real and that you will feel. If this video gave you something useful, comment the word "protect" below. It tells me you are taking this seriously, and it helps this information reach the people who need it. In the next video, I'm going to show you a specific vitamin deficiency that affects 1 in 3 adults over 60, that causes memory loss, brain fog, and confusion, and that almost every standard blood test misses entirely. It is not the vitamin you are thinking of, and the form your doctor likely recommends is not the form that actually reaches your brain. Your brain is not broken, it adapted, and when you give it what it needs, it adapts back. Not instantly, but reliably. I will see you in the next one.